Alright, so I think I'm recording. Let's take a look at our Skill 3 review problems. Let's see what we have here. Alright. We want to describe this collection of numbers that's shaded here on the number line using interval notation. When you have a solid dot, you include that endpoint. In interval notation, that's a bracket. And you always start with the smaller numbers, comma, larger numbers. So then over here, the other endpoint, 2, is excluded. 2 is not in this set, so we have an open parenthesis. For set builder notation, you always have a brace, and it starts out, well, the phone is ringing. I'll have to pause. Alright, I think I'm back. I was in the process of describing this set of numbers using set builder notation. The braces here, this is read x, the set of all x, such that and x is an element of the real numbers. Now for us, when they say set builder notation, just memorize this first part. This is always going to be there. Now, in your inequalities, you do not have positive or negative infinity in your inequalities. We can write this as a compound inequality. We have negative 4 is less than or equal to x, which is strictly less than 2, and we close it with a brace. So there's our answer for part 1. Let's go ahead and put problem 2 on the same video. So let's grab, where did it go? There it is. So in interval notation, again, we start with the smaller numbers. The arrow is shaded here. That's indicating that this is going all the way to negative infinity. That's not a number. We can't include it. We always have to have an open parenthesis around negative or positive infinity. But this is smaller than all of the other numbers, so there are no holes or jumps until we get to 6. And since it is a hole, we have a parenthesis, and that's how we would describe all of these numbers that are shaded in interval notation. In set builder notation, we have a brace, the set of all x, such that x is a member of the set of real numbers, and x is strictly less than 6. You will never have, since positive or negative infinity is not a number, you can't have an inequality to compare it against. So there's our answer for number 2. And let's go ahead and do 3 since it's the same style of problem. Now this time we notice that there's more than one interval that's shaded on the graph. We have a break in the graph, so we'll need to use a symbol that's called a union. And in interval notation, we're excluding the endpoint negative 7 all the way to positive 5, and we're excluding that. Union, and that symbol is just looks like a big capital U. 5, and since it's being excluded, it's important to have these be open parentheses. And then since the arrow is shaded, we're going all the way out to infinity, and we need an open parenthesis. We'll never have a bracket around positive or negative infinity. So when we have a break in our shaded interval, in our shaded region, we'll need a union. Using our set builder notation, we have the set of all x, such that x is a member or an element of, that's what that little epsilon means, an element of the set of real numbers, and they usually write real numbers with an extra little thing there. when you're writing with pencil and paper, you really can't make it bold. So I guess that's their way of making it bold. This first interval, we can write it as a compound inequality, that -7 is less than x, which is less than 5. And then again, just like the union here, we need a union, and now x greater than 5. So there's problems 1 through 3. I hope that helps, and I'll talk to you later.